Okay, integration. Integral. We only have 4 methods. The first one being extended power rule. Meaning if f of x, here we do this, integrate x to the power n. Extended power rule says add the 1 to the n, divide by the same as a c. An example, integrate x 3 plus 2x plus 1 dx. So you say the integral of this is x4 over 4 plus 2x squared over 2 plus x plus a constant. So it becomes x4 over 4 plus x squared plus x plus c. The idea is when you differentiate your answer, it must give you the question. Another example, root t plus t dt. So you say this is the same as what? T to the power half plus t dt. And then you say t half plus 1 over half plus 1 plus t squared over 2 plus c. This is t 3 over 2 over 3 over 2 plus t squared over 2 plus c. But this is 2 over 3, t 3 over 2 plus t squared over 2 plus c. This is called extended power rule. In case you have forgotten, if they say 0 to 3 and they bring x squared plus 1 dx, they mean you integrate normally plus x and substitute. Where there is x, you take 3 first, put in the brackets, subtract. Where there is x, you take 0. So you will get 27 over 3 plus 3 minus 0, which is 9 plus 3, which is 12, like that. Let it go on again. So you do that. Then we call this extended power. Second method, we call it substitution. Substitution is when I have to integrate a question that is sitting in this manner. Maybe I say power n there. So I'll integrate it. This question will be integrated as un plus 1 over n plus 1 plus c. What is the difference between the two? The difference is that here we mean questions like x squared plus 1 to the power 7 multiplied by x dx. When you look at the inside, if we let what is inside power 7 to be u, it will be x squared plus 1 du is going to be 2x dx. So I can solve for dx. I divide by 2x so that my dx, this part cancels, becomes du over 2x. So now I go back there and say this is u to the power 7, and x dx will be x, dx is du over 2x. So that x and this x will cancel and remain with u 7 1 over 2 du. So that I have 1 over 2 u to the power 8 over 8 plus c. That's what I meant by saying u. So it will be u to the power 8 over 16 plus a constant c, but u is x squared plus 1, power 8 over 16 plus a c. That is the integral that we deal with. We can have nice questions here. Questions like, can x sec squared x dx? If you have a good memory, you will remember that the derivative of tan is actually sec squared x dx. Then you come here and write this as u du, then you integrate it u2 over 2 plus c. But we said u is tan, so you just do that. You're done. Questions like sin x cos x dx. You simply say u is sin x, du will be cos x dx. Suppose I wanted to integrate an exponential function. Say what is the integral of e to the power that du. So provided that the u is in this form, say I have e to the power 3x plus 1 dx. If my u, which is 3x plus 1, has the derivative, which is a constant, then the integral is 1 over that constant, e 3x plus 1 plus ac. That's all. The only thing I'll never do is to take a variable in the denominator. That's why I've emphasized like that. Alternatively, I want to integrate. Anyway, this was substitution. But if I have du over u, then my answer will be ln u plus c. What do I mean by that? For example, I'm integrating 1 over x plus 2 dx. Since the derivative of x plus 1 is 1, then the answer is going to be ln x plus 2 plus c. So every time I want to go deep, I remember that we did a very serious discussion on this. Then I come back to the surface. Is that a question?
Yes, kindly repeat on the previous slide.
You pick a question to be repeated here.
The last part of the first question.
For the first question, you want to integrate this. Now, x squared plus 1 has the power 7. We can't manage to expand that whole thing. So what do? We let u to be the inside thing in the brackets, then differentiate it. So we look for du, which is going to be, derivative of the inside is 2x dx. Then we solve for dx, so you divide by 2x, divide by 2x, you get that dx is equal to du over 2x. I take this where there is dx here, it is here. And I've left the x there. This part I've said it is u, so I have u power 7. But that x and the x that is on the dx cancels. I've remained with it. 1 over 2, this 2 I can take it outside. So I have 1 over 2 u to the power 7 du. But we said this is how we integrate u. So it will be u to the power 8 over 8 plus c. 1 over 2 is outside. But 8 and 2 will multiply, I'll get 16. And I have u power 8 over 16 plus c. What is u? U is x squared plus 1. So I put x squared plus 1, 8 over 16 plus c. That becomes my integral.
Then for the sine and cos, how do you know which one makes you?
The one which is the derivative of the other becomes du. What du means is, it means that when you say u and du, you mean this function, its derivative is this one. So if I have tan and sec squared, the derivative of tan is sec squared. So I'll make tan to be u. So the sec squared is the du. And that is how I know.
So, sir, from here, don't you expand it, or you just leave it here?
Which one do you expand?
The same, the integral of u du. You just leave it here, or you can expand it further.
For example, x squared. For example, x
You
squared plus 1 to the power 8.
I mean on this same question here where you found the integral of u and du. Can you now substitute since our u we know and the sec we know? We have to substitute and solve it further. Oh, okay. It will take us back. It's okay.
All right. Thank you. So that is, this was the example on the lean. This is the example on the exponential. So I've done both. Now we go to by parts. By parts,
Hey, sir, I'm asking for the previous page. I just want to check on how you solve the lead.
so by parts we'll have, if I have products of functions that I can name in this way, then the integral will be this. A good example is if I have x ln x dx. Here, I'll say let u be ln x. Why? Because I can differentiate u. Du is 1 over x dx. I'll let dv to be x dx. Why? Because I can integrate to get v, which is x squared over 2. If I cannot integrate, I can never say it is dv, because my dv is the one I'm able to differentiate, to integrate. My u, the one I'm able to differentiate. So the integral here now becomes uv, which is x squared over 2 ln x, minus the integral of v du, which is x squared over 2 multiplied by 1 over x dx. This is x squared over 2 ln x minus x there, 2 there. So the 1 over 2 can go out and x dx remains there. But we just integrated that. So you can integrate it again. And we get x squared over 2 plus a c, which is x squared over 2 ln x minus x squared over 4 plus c. And that's how you do the by parts. So it's by parts because I'm able to see. Another example is x e to the power x dx. This one, you always let the polynomial to be the u and the exponential to be the dv. Because when we integrate the exponential, we just get the very exponential. Because the down part there is 1. When you differentiate x, you get 1 dx. So when you substitute, you get x ex minus the integral of ex dx. But this is just x ex minus ex plus ac. Really easy one. Then you do examples of which nature? No. Then you do partial fractions. If I tell you to integrate x3 over x minus 1, x plus 2.
Sir,
Hello.
can you repeat on the second example? One is
We repeat here.
yeah, the second one.
Okay. So I said you let your polynomial to be x, the polynomial to be u, and the exponential to be dv. Integrate the exponential, you get the very exponential. Because x there, the power, its derivative is 1. Differentiate x, you get 1. And then substitute them in that order. Following the formula there. And then integrate the exponential again. And you just get itself. And then you divide by, you add the constant. I want to integrate
Thank you.
this. Okay. So I'll say x3 over x minus 2 x plus 2 dx. From there, I will leave the integral first. I will deal with this part. First, I solve it into partial. Then I multiply by x minus 2 x plus 2. So it will be x3 is equal to a x plus 2 plus b x minus 2. And when x is 2, we'll have, where there is x3 there, we'll have 2 to the power 3 is equal to a 2 plus 2 plus b 2 minus 2. Now this is 0. 2 plus 2 is 4. So we have 8 is 4a. So that a is 2. But when x is -2. We have -2 to the power 8 is A -2 plus 2 plus B -2 minus 2. So we have -8 is -4B, and this is going to give us B is equal to 2 as well. So what we have now is this integral is the same as the integral of 2 over x minus 2 dx plus 2 over x plus 2 dx, which can also be written as 2 outside 1 over x minus 2 dx plus 2 outside 1 over x plus 2 dx. And the integral of this one, remember, that's where ln comes into play now, because the denominator has the powers 1 for x. So that becomes our integral. So that is how we get that as required. And this is what we call partial fraction. Applications of this is where they put the limits here. So you just substitute them. That's what you call application. Or they give you something that is sketched. They give you a graph. They give you a graph. And they ask you to find this area here. So I demonstrated where you get the intersection. You get this A, that to B, and
Before
integrate
you
from A to
continue,
B.
or you've included it, but there's a question that I checked the textbook. The two here that you've included here, we're not including it. I don't know why.
You are making a mistake.
But the second one, like 1 over x plus 2. The 2 was not being included.
It was an error. Okay, so this is where we end. All the best tomorrow.
How about applications?
That's why I'm saying that for applications, that question we did on this one, where you get the upper function minus the lower, and in the integral you substitute A and B. That is what you call applications of integration. So if you have forgotten, go back to that video and check what we did there.
Okay, thank you, sir.
All right.